It starts small. A tightening in your calf while you sleep. A sudden seize in your hand while you write. A knot in your foot that curls your toes without permission. You know this feeling, everyone does. And you know how it ends too. It hurts, it peaks, and then, after a few brutal seconds, it lets go. But what if it didn't? What if that same muscle right now decided to stay locked? Not for 10 seconds. Not for a minute. Forever. Stay with me because by the end of this video, you'll understand something most people never think about. That a cramp is not just an annoying twitch. It's a war happening inside your own muscle fibers. And if that war never ended, your body would start destroying itself from the inside out. Let's go inside that muscle and find out exactly what would happen. The machine that never stops. To understand what happens if a cramp never releases, you first need to understand what a cramp actually is. Inside every muscle you own, there are millions of microscopic fibers built from two proteins called actin and myosin. Think of them as tiny rowers on a boat, pulling on ropes in perfect rhythm. When your brain sends a signal to move, calcium floods into the muscle cell, and those two proteins grab onto each other and pull. That pull is what creates motion. Normally, after the pull happens, the calcium gets pumped back out, the proteins release their grip, and the muscle relaxes. This entire cycle depends on one thing you rarely think about: energy, in the form of a molecule called ATP. A cramp happens when that release signal misfires. The calcium stays flooded in. The rowers keep pulling. The muscle stays locked in a full, forceful contraction, using energy nonstop, with no rest phase at all. Now imagine that instead of stopping after 20 seconds, it just didn't. Before we go further, if you're the kind of person who likes understanding what's actually happening inside your own body instead of just accepting it, go ahead and hit subscribe now, because this channel breaks down exactly this kind of hidden biology every single week. The first 10 minutes. Let's say the cramp is in your calf. In the first few minutes, your muscle fibers are contracting at near maximum force, burning through ATP at a rate they were never designed to sustain. Under normal exercise, muscles alternate between contraction and relaxation, which allows blood to keep flowing in and out. But a locked, sustained contraction does something dangerous. It physically squeezes the tiny blood vessels running through the muscle tissue, cutting off its own blood supply. This means the muscle is now working harder than ever, while receiving less oxygen than ever. Doctors have a name for this exact combination: ischemia. Your muscle is suffocating while still being forced to work. Within minutes, your body starts producing lactic acid and other byproducts far faster than the blood can carry them away, because the blood flow is restricted. That buildup is part of why an ordinary cramp is so painful. Now stretch that pain out and imagine it compounding instead of resolving. 30 minutes. In. By this point, something worse begins. Without a steady blood supply, the muscle cells start running out of ATP entirely. And this is where things take a dark turn, because ATP is not just fuel for contraction, it's also required for relaxation. The same rowers that need energy to pull the rope also need energy to let go of it. This is the same underlying mechanism behind a phenomenon you may have heard of in a completely different context: rigor mortis. After death, cells stop producing ATP, and without it, actin and myosin stay locked together because they physically cannot release without energy. That's why a body becomes stiff after death. It isn't the muscles are contracting on purpose. It's that they're frozen mid-grip with no fuel to let go. A cramp that never ends is heading toward that same trap, in a muscle that is still very much alive. 1 hour in, the point of no return. At around the 1 hour mark, without intervention, doctors would tell you the tissue has entered a genuinely dangerous state. Muscle cells deprived of oxygen and energy for that long begin to die. This is called ischemic necrosis, and it's the same underlying process seen in a serious medical condition called compartment syndrome, where pressure inside a muscle compartment cuts off circulation so severely that the tissue starts dying within hours if it isn't relieved. As the muscle cells die, they rupture and release their internal contents into the bloodstream, including a protein called myoglobin. In large amounts, myoglobin is toxic to your kidneys. This is not a hypothetical detail, it's an actual medical emergency called rhabdomyolysis, and it can occur in real patients after extreme, prolonged muscle strain, seizures, or crush injuries. If this reached the level our imaginary permanent cramp is describing, it could genuinely put your kidneys at risk. So here's your first answer to the loop we opened. A cramp that truly never released wouldn't just hurt. It would eventually kill the muscle tissue itself. But here's where it gets even stranger, because there is a real medical condition where muscles genuinely do lock up and refuse to let go. And understanding it tells us exactly why your body is built to prevent this from happening to you. When the body actually does this. Tetanus. The disease tetanus is caused by a toxin from a bacteria called Clostridium tetani, and it's often called lockjaw for a reason. That toxin blocks the nerve signals responsible for telling muscles to relax. The result is uncontrolled, sustained muscle contraction, sometimes severe enough to lock the jaw shut, arch the spine backward, and make breathing physically difficult, because even the muscles you use to breathe can become locked mid-contraction. Before modern vaccines, tetanus was one of the clearest real-world examples of what happens when the relaxation signal in muscles simply stops working. It is, in the most literal sense, the human body experiencing a cramp that refuses to end in multiple muscle groups at once. And it shows just how catastrophic that failure can be if it isn't reversed quickly. This is exactly why your body is so aggressively designed to prevent ordinary cramps from ever reaching that point. If this is blowing your mind a little, that's exactly the reaction I'm going for. So drop a comment below telling me the weirdest cramp you've ever had, because I read every single one. And don't forget to like this video so more people see how strange the human body actually is. Why your body refuses to let this happen to you. Here's the twist in our loop. Your nervous system has a built-in safety mechanism specifically designed to prevent a normal cramp from becoming a permanent one. It's called reciprocal inhibition. When a muscle contracts intensely and abnormally, sensors inside the muscle called Golgi tendon organs detect the dangerous tension building up, and they send an emergency signal back to the spinal cord, telling that muscle to stop firing. This is also the exact scientific reason why stretching a cramping muscle works so well. When you pull your toes back during a calf cramp, you are physically triggering these tension sensors, forcing your nervous system to override the contraction signal and force relaxation. You're not just easing the pain, you're activating a biological safety switch. Blood flow returning is the second half of the recovery. Once the muscle relaxes even slightly, circulation resumes, oxygen returns, ATP production restarts, and the lactic acid buildup finally gets cleared out. This is why an ordinary cramp, however painful, almost always resolves within a minute or two. Your body is fighting to prevent the exact scenario we've been describing this entire video. So, what would it actually take? For a cramp to genuinely never end, something would have to disable this entire safety system. The nerve signals would have to be blocked entirely, the way tetanus toxin blocks them. Or the muscle's ability to make ATP would have to fail completely, the way it does after death. In other words, under normal, healthy conditions, a truly permanent cramp is almost biologically impossible because your own body is built with multiple overlapping systems specifically to stop it. The pain you feel during a bad cramp isn't a design flaw. It's a warning system working exactly as intended, urging you to move, stretch, and force that muscle back into balance before it can spiral into the kind of damage we just walked through. So the next time your calf locks up at 2 in the morning, you'll know exactly what's happening at the cellular level and exactly why your body is racing to stop it before it becomes something far more dangerous than a few seconds of pain. If you want more videos that break down the hidden biology hiding inside completely ordinary moments like this one, make sure you're subscribed, because next time we're going inside a completely different everyday sensation and showing you the science most people never learn.